Welcome to another episode of AI 10X brought to you by 10 Leaves. So, imagine for a second trying to have a fluid, natural conversation in a really crowded room, but every single word spoken to you arrives on a 10-second delay.
Oh, that would just be completely maddening.
Right. Or, imagine trying to navigate a busy city sidewalk where your only input about the physical space around you is, well, just a single monotonous beep.
Just a beep telling you something is nearby, but no context on what it actually is.
Exactly. And that is, unfortunately, the frustrating reality of outdated accessibility technology for so many people. But today, we're diving into how artificial intelligence is stepping in to basically reduce that latency to zero.
Yeah, it's really completely remapping how we experience the world.
It is. Usually when the topic of artificial intelligence comes up, the conversation just immediately gravitates toward convenience, right?
Oh, always. It's always about, algorithms predicting your next email reply or,
Yeah, or some software automating a tedious spreadsheet for you. But we have a stack of research and notes today centered around this incredible source titled Breaking Barriers. AI is an architect of inclusion.
and it really demands a total reset of that convenience narrative, doesn't it?
It really does. The mission for our deep dive today is to explore AI as a fundamental enabler of accessibility for individuals with disabilities.
Which completely reframes the technology. I mean, we aren't talking about convenience tech here. We are talking about empowerment tech.
Exactly. Empower.
When you look at the material provided by 10 Leaves, you really start to see AI as this crucial bridge between a person's intent and their physical or, sensory environment.
Right, because if you're listening to this deep dive on a smartphone right now, or maybe driving a car, you likely take for granted that the physical and digital interfaces around you were built for, well, your specific physical capabilities.
Yeah, your environment is relatively frictionless. You don't even think about it.
But when the world isn't designed for how your body or your mind operates, that exact same environment is just this relentless series of barriers.
And what the source material argues so well is that AI is actively dismantling those barriers. It's changing the baseline of what is possible for millions of people, and it's doing it in real time.
Yeah, and the source notes we're working from use a very specific phrase that really caught my attention. They point out how AI improves accessibility by helping people navigate the world independently.
Right, navigation.
Yeah. And to illustrate that, they point to things like speech-to-text and vision assistance. Now, if you just glance at those two examples, you might think, oh, those are just basic utilities.
Sure, like a digital magnifying glass or something.
Exactly. But navigation implies a lot more than just a basic utility. Normally, we think of navigation as GPS or maps, right? But for someone with a disability, navigating the world independently means translating the physical world into an accessible format.
Yes, that translation is key.
Okay, let's unpack this. How does AI take something like speech-to-text or vision assistance and turn it from a basic utility into a true navigation tool?
To understand that leap, you really have to look at the mechanisms driving the software. Let's take vision assistance first.
Okay, vision assistance.
Historically, a digital tool for someone with a vision impairment was often just an obstacle avoidance mechanism.
Right, like we mentioned earlier with the beeping.
Exactly. Think of a proximity sensor built into a cane or, a wearable device. It pings or vibrates if you get too close to a physical object.
Which I guess prevents a collision.
It does, but it doesn't give you any context about your surroundings. You still don't know if that obstacle is a trash can or a descending staircase or just a person standing perfectly still.
Oh, wow. Yeah, that's a huge difference.
Huge. And AI changes that by bringing semantic understanding to the physical world through computer vision. If we connect this to the bigger picture, it's about actually comprehending the space.
So instead of just registering that, some mass occupies a certain physical space, the system actually comprehends what that mass is.
Yes. A modern AI vision assistant uses the smartphone camera to ingest this continuous stream of pixel data.
Just constantly reading the room.
Exactly. But it runs that data through object detection algorithms that have been trained on millions of images. It identifies the objects, it reads text using optical character recognition, and it even maps the spatial relationships using the phone's built-in depth sensors.
So it isn't just saying obstacle ahead.
No, not at all. It can synthesize the scene and actually tell the user there's an empty chair 3 feet to your left, or, the crosswalk sign across the street is now flashing the walk signal.
But wait, that requires an enormous amount of processing power to happen on the fly. I mean, if you were relying on that system to cross a busy intersection, it can't take 5 seconds to buffer and analyze the image.
No, not at all.
The latency has to be virtually non-existent, right?
The latency is the entire ballgame here. If an AI takes 10 seconds to process a camera feed and inform you a car is approaching.
It's too late.
Yeah, the technology is worse than useless. It's actively dangerous. And this is where edge computing comes into play.
Edge computing. Okay, explain how that solves the latency issue.
Well, instead of sending the visual data up to a cloud server, waiting for a remote data center to process it, and receiving the audio description back, modern AI models are compressed.
Oh, so they're optimized to run locally.
Exactly. They run directly on the hardware of the smartphone. The phone itself acts as the localized brain, which allows for instantaneous, context-aware processing.
That's incredible. So the device is acting almost like a real-time translator for the physical environment, narrating the spatial map instantly.
That's exactly what it is.
And that same logic seems to logically bridge over to the other sensory software mentioned in the text, which is speech-to-text.
Right, which most of us just use to fire off quick text messages when our hands are full.
Yeah, exactly. But the source frames this as a core component of accessibility. So how does that jump from convenience to navigation?
Think about the older iterations of speech recognition. They relied heavily on acoustic modeling, essentially trying to match the specific audio frequency of your voice to a pre-programmed phonetic dictionary.
Which meant you had to speak with, like, robotic precision.
Right. You had to over-enunciate, pause between every single word. And even then, the system still struggled with accents or any background noise.
Which basically meant you had to adapt your natural behavior to accommodate the rigid limitations of the machine.
Exactly. You were doing the work.
Which is an incredibly frustrating dynamic, especially for someone who might have a speech impediment or, for someone who is deaf relying on that software to read what a colleague is saying in a crowded, noisy room.
The rigid system completely fails in those edge cases. But AI-driven speech-to-text fundamentally alters that dynamic by using deep learning natural language processing, or NLP.
Okay, so how is NLP different from the old acoustic models?
It doesn't just listen for isolated audio frequencies anymore. It uses massive neural networks to predict the linguistic sequence based on the context of the entire sentence.
Oh, wow. So it's looking at the big picture of what's being said.
Yeah, it's trained to differentiate human vocal patterns from the ambient clatter of a coffee shop. If a word is slightly slurred or muffled, the AI can accurately infer what that word was based on the grammatical structure around it.
So it actually understands language, not just sound.
Precisely.
That shift from the human adapting to the machine actually adapting to the human, that is profound.
It really is.
And it actually sets up the next major piece of our source material perfectly, because we've been discussing software that helps people perceive the world.
Right, the sensory bridge.
But the text also moves into hardware and apps designed to help people move through and interact with the physical world. And the notes highlight 3 standout examples: AI-powered prosthetics, real-time translation, and assistive apps.
Yes, those are the big 3 they focus on.
Now, I want to push back on the first one a little
Okay, let's hear it.
We've had prosthetics for centuries. I mean, historically, humans have been designing replacement limbs since ancient Egypt. So what makes an AI-powered prosthetic such a completely different paradigm? Why is it the standout example the source claims it is?
That's a great question. Let's examine the mechanics of a traditional prosthetic to really see the contrast. Take a conventional mechanical leg.
Okay.
To use it, the individual has to physically swing their hip in a very specific and often exhausting biomechanical rhythm.
Right, they have to generate the momentum.
Exactly. They have to force the mechanical knee to bend and lock at the precise moments necessary to take a step. The human brain's ability to rewire itself, its neuroplasticity, is doing all the heavy lifting.
Wow, okay. So the user is basically operating a manual machine using their residual muscles. They have to consciously manage the mechanics of every single step. They adapt to a static tool.
They adapt 100% to a static deadweight tool, but an AI-powered bionic limb changes the fundamental architecture of that relationship.
How so?
Well, these modern prosthetics are embedded with microprocessors, gyroscopes, and sensors that read myoelectric signals.
Myoelectric signals, meaning electrical signals from the muscles.
Yes. When a person intends to move, their brain sends a tiny electrical impulse down the nervous system to the residual muscle. The sensors on the prosthetic socket pick up those myoelectric spikes.
Wait, really? So the limb is reading the electrical intent to move before the physical movement even fully happens.
Yes. And it feeds that data, along with data about the user's momentum and the angle of the ground, into an onboard neural network running 1,000 times a second.
That is mind-blowing.
It's constantly learning the user's specific, unique gait. It predicts what the user wants to do next. So if you transition from walking on flat pavement to walking down a grassy decline,
You don't have to consciously adjust how you swing your hip to prevent the knee from buckling.
no, you don't. The AI detects the change in terrain and resistance instantly. It adjusts the fluid actuators in the knee to dampen the step. The machine actively adapts to the human.
That completely transforms the concept of a prosthetic. It's no longer just a rigid tool you strap on and wield. It's functioning almost like an extension of your peripheral nervous system.
Exactly.
It's anticipating intent and handling the biomechanical execution, which has to massively reduce the cognitive and physical load on the user.
Absolutely. And again, if we connect this to the bigger picture, that concept of a dynamic learning tool is the connective tissue linking the AI prosthetic to the other examples in the text.
You mean the real-time translation and the assistive apps?
Yes. In every case, the AI is acting as an adaptive tissue designed to road around a specific barrier. With the bionic leg, the barrier is physical mobility. But with translation and communication apps, the barrier is cognitive or communicative.
Right. Let's dig into that communicative barrier for a second. If an individual's nonverbal and relies on an assistive communication app, historically they might have had to slowly type out words on a keyboard, right?
Right, or select icons one by one on a screen to generate synthesized speech.
Which completely shatters the natural rhythm and flow of a conversation. It places an immense burden on the user to manually operate the system.
It's exhausting. But inject AI into that process and everything speeds up. Modern assistive apps use predictive text models that are tailored to the user's specific vocabulary and speech patterns.
So it learns how they naturally speak.
Exactly. They can even integrate with eye-tracking hardware, allowing a user to rapidly construct complex sentences just by looking at a screen, while the AI predicts the intended thought.
Wow.
Or consider real-time translation, specifically for sign language.
Now, translating sign language presents a massive technical hurdle. Right. Because it isn't just about reading hand shapes.
Not at all.
American Sign Language has its own complex grammar, and it relies heavily on facial expressions, the speed of motion, and the physical space around the signer.
It is an incredibly complex 3D spatial mapping problem. An AI translating sign language has to use a camera to map a digital skeletal wireframe over the user in real time.
The digital wireframe.
Yeah. It tracks the exact position of the fingers, the angle of the wrists, the movement of the shoulders, and as you mentioned, the expressions on the face.
That's a staggering amount of data to process.
It synthesizes all of those simultaneous visual data points, translates the conceptual meaning into spoken English, and outputs it through a speaker. And it has to do it instantly.
It really makes me think of a comparison. It's like using the old rigid accessibility tools is like traveling in a foreign country with nothing but a heavy, rigid phrase book.
Oh, that's a great analogy.
Right. You have to manually look up every single word. You have to force the interaction to a grinding halt just to adapt to the limitations of the book. It works, eventually, but the burden of communication is entirely on your shoulders.
Exactly.
But what these AI technologies are doing, whether it's the bionic limb handling the terrain, the vision app narrating the room, or the spatial translation of sign language, it is literally like having a fluent, real-time bilingual interpreter living in your ear. The AI absorbs the friction of the interaction.
That is the crucial takeaway. The AI is absorbing the friction, and when you eliminate that friction, you open doors that were previously walled off.
Yeah, you really do.
And the doors we are talking about aren't just literal entrances to buildings. They are the doors to education, to employment, and to social participation.
Which brings us to the core societal impact identified in the source text. So what does this all mean? When assessing the ultimate result of this technology, the source states it creates, quote, greater independence and equal opportunity.
Equal opportunity. It's a huge concept.
We hear that phrase constantly in society, usually framed as a moral baseline or an ideal. But equal opportunity is not a naturally occurring phenomenon, is it?
No, it's really not.
It's not the default state of the world. It has to be actively engineered.
What's fascinating here is look at the precise phrasing in the title of the notes. AI as an architect of inclusion. Architecture is deliberate. It is structural design.
Yes, deliberate design.
Inclusion does not just mean holding the door open so someone can enter the room. It means designing the architecture of the room so that everyone can navigate it and contribute their skills on their own terms.
Exactly.
Because when an individual has to spend 80% of their physical or cognitive energy just managing the logistics of a world that was not built for them, they do not have equal opportunity. They are starting every single day wearing a heavy backpack.
Think about the practical reality of that. If a brilliant student who happens to be blind has to wait 2 weeks for a university textbook to be manually converted into Braille or, some accessible digital format,
Yeah, 2 whole weeks.
while their sighted peers get the information instantly on the first day of class, that is a structural failure of equal opportunity.
But apply the technology we've been discussing today. If that same student has an AI-driven vision assistant on their phone that can instantly ingest the standard textbook.
Just right there on the desk.
Yes. Accurately read the text aloud, interpret the complex data within the graphs, and semantically describe the diagrams in real time. The friction vanishes. The heavy backpack is taken off.
The AI has engineered a level playing field.
Exactly. And the same structural shift happens in the workforce.
Right. If you have a professional with a hearing impairment trying to participate in a fast-paced corporate video conference, a 5-second delay in captioning means they're constantly missing the context of the conversation.
They're always a step behind.
But if an AI model running locally on their machine is providing flawless, zero-latency captions that can actually differentiate between multiple speakers overlapping each other, well, their disability ceases to be a barrier to their economic participation.
This completely upends the mainstream anxiety surrounding artificial intelligence. I mean, so much of the public discourse is rooted in the fear of obsolescence.
Yeah, the fear that AI is going to replace human capability.
Right. But in the context of accessibility and disability, AI is doing the exact opposite. It is not replacing human capability, it is restoring it. It is amplifying it.
It's removing the barriers.
It is removing the mechanical and sensory barriers so that the individual's true intent, intellect, and capability can actually shine through.
It really proves how deeply intertwined the concepts of independence and opportunity really are. I mean, independence isn't just a matter of convenience, like not having to ask someone to reach a high shelf for you.
No, it's so much deeper than that.
It is fundamentally about dignity. It is about possessing the autonomy to move through your physical environment, to articulate your thoughts seamlessly, and to pursue your ambitions without having to constantly petition a rigid system for accommodations.
Exactly.
When individuals can navigate their world independently, society as a whole gets the benefit of their unfiltered participation. We basically stop losing out on immense amounts of human potential simply because of poorly designed interfaces.
It is a remarkable shift in how we build our world, and it leaves us with a really fascinating macro-level concept to consider.
Oh, what's that?
Well, the very last line of the source material from 10 Leaves is brief. It simply says, next global development.
Oh, right.
It is presented as a prompt for the future. But if you take the underlying mechanisms we have discussed today, if AI can act as an adaptive tissue that successfully rewrites the rules of accessibility, dissolving specific complex barriers for the individual.
What happens when we scale that exact same architecture up to global development?
Exactly.
Wow. So if we can engineer equal opportunity for one person by using AI to route around a sensory or physical roadblock, can we engineer that same level of equal opportunity for entire developing nations?
That's the question.
Can AI serve as the adaptive tissue that bridges massive gaps in global infrastructure or education systems and healthcare distribution?
If the technology can map the spatial grammar of sign language or predict the myoelectric intent of a footstep, it stands to reason it could be deployed to optimize agricultural supply chains in drought-stricken regions, right?
Yeah, absolutely.
Or provide real-time, highly accurate medical diagnostics in areas completely without localized healthcare infrastructure. The core principle remains the same: using dynamic, learning software to eliminate structural friction.
That is an incredible thought experiment to wrap up on. The idea that the exact same neural networks and processing mechanisms providing autonomy to a single person navigating a coffee shop could be scaled up.
Scaled up to a global level.
Yeah, to provide economic and infrastructural autonomy to a whole society. It forces you to look at the future trajectory of this technology in a completely different light. It's not just about building smarter gadgets. It's about architecting a more accessible reality on every single level.
It really is.
Well, that is certainly something for you to mull over as you go about your day. Thanks for joining us for another episode of AI 10X, brought to you by 10 Leaves.